All right. Hey, AP Chemistry. I wanted to give another couple of helpful hints with what I do with the equilibrium expression if I were to flip the reaction, if I were to multiply or half the reaction, what happens to Kc? First, I want to start off by writing a Kc expression for something like this. Remember, we don't include solids in our equilibrium expression, so if I were to write a Kc expression, it's supposed to be the concentration of the products over the concentration of the reactants. And remember, solids and liquids, they're not written in the equilibrium expression because their concentration is constant. So instead of writing zero, it doesn't mean zero. It doesn't mean that they don't have a concentration. It means that their concentration is constant. For us, if we want to represent something as being constant, we could just put the number 1 in its place. It doesn't matter. So if I want to write the Kc for this, technically I would have done CaCO3 over CaO times CO2. However, I'm not writing CaCO3, and I'm not going to write CaCO. So let me write it the wrong way, and then cancel out. So technically I would do CaCO3 over CaO times CO2, and they're all raised to the 1 exponent. Well, I'm not including that in it, and I'm not including that. I'm not including CaCO3 because it's a solid, and I'm not including CaO because it's also a solid. So really, I'm just going to write that as 1 over 1 times the concentration of CO2, which is just 1 over the concentration of CO2. So if I end up having only one reactant or one product in my equilibrium expression, that's fine. Just remember, we put your products on top and you put your reactants on the bottom. In this weird instance where I only have one thing in my equilibrium expression, and that's a reactant, I would just put it 1 over that reactant's concentration. All right? So now let's say I want to invert the equilibrium expression. All right, if I'm inverting, I'm going to do CaCO3 solid in equilibrium with CaO solid plus CO2 gas. And I wrote up here that the Kc is 50. Well, my original equilibrium expression was 1 over CO2. This Kc would be equal to just CO2, right? Because I would have, this is the only thing in my products, and I don't even include that in my reactants. That looks like this Kc, I'm going to call this invert 1, Kc1, right? It looks like this Kc is the inverse of the original Kc. So basically, if I wanted this Kc of the inversion, I would do the inverse of 50. So if I invert, I'll just do the inverse of the Kc. Okay? So my original Kc was 50. My Kc for the invert is just going to be 1 over 50, which is whatever number that is. Okay? That is how you work with the equilibrium expression if I were to invert or switch the reaction. So my original Kc was 50, and that's for this reaction. For this Kc, it looks like it's the inverse of this. So all I do is I just do 1 over 50. Okay? If I were to multiply by a constant, okay, I'm going to zoom up now. Let's say I go to my original reaction, right? If I were to multiply CaOS plus CO2 gas in equilibrium with CaCO3 solid, let's say I multiplied this whole expression by 3. So 3, 3, and 3. If I were to write my equilibrium expression, again, this would be, I wouldn't include CaO, I wouldn't include CaCO3. The only thing I would include would be CO2, and it would be in the denominator like I had earlier. But instead, since there's a 3 here, it would be 1 over the concentration of CO2 cubed. So what is the relationship between this and this? It looks like my Kc would have to be cubed. So whatever I do, whatever I multiply by is whatever I raise my Kc to. So I'm going to call this multiply 2, right? Just because it's the second thing I'm doing. My Kc2 would be equal to my original Kc, and I would just cube that. Okay? So that would be, my original Kc was 50, and I would just cube it. Okay? So that is what happens when I invert an equilibrium. I just do the inverse of Kc. So my original Kc was 50. In order for me to invert, I would just do 1 over 50. If I multiply by a coefficient, remember that multiplication ends up as an exponent in the Kc expression. And so since this is still my same Kc expression and that Kc was 50, since I cubed this, or if I multiplied the whole expression times 3, I would have to cube my Kc. So I wanted this to just be a brief video to help you all out on what would I do if I were to invert or multiply my equilibrium expression, and how to write equilibrium expressions if I only have one reactant or product that's a gas or aqueous. Remember, last thing I'll say is for equilibrium expressions, we only include gases and aqueous. Solids and liquids are not written in the equilibrium expression because their concentrations are constant. So remember that in the future. The concentration of a solid or a liquid is constant, and that's not going to show up in the equilibrium expression because it's just like multiplying by a constant. So I hope this little tip was helpful for future reference. Let me know if you have any other questions or concerns. I probably am going to make one more video where if I have two Kc expressions, what do I do with them to write an overall Kc?